You know that sound, right? That super high-pitched, squeaky voice you get after sucking in a bit of helium from a party balloon? It's hilarious. But what if I told you the reason we think it happens is totally wrong?
Yeah, everyone asks this question. The go-to answer for years has been, oh, helium raises the pitch of your voice. Makes you sound like a chipmunk, right? It seems so straightforward, so obvious. But is that really what's going on?
Spoiler alert? Nope. It absolutely does not. That's the myth we're busting today. Helium does not change the pitch of your voice. Seriously, your vocal cords, they're vibrating at the exact same speed as they were before. So to get to the bottom of this, we've got to go back to basics. Like, what even is sound? Okay, so what is sound, really? Before we can get why helium messes with our voice in such a funny way, we need a solid handle on what sound truly is. And let me tell you, it's way more than just some wavy line on a computer screen. It's a real physical thing happening all around us, all the time. And this image here, it really shows what I mean. Sound isn't some magical force. It's physics in action. It's literally a wave of pressure pushing its way through the air. You can think of it like ripples spreading out in a pond after you toss a stone in. It's a physical wave of energy traveling from, say, my mouth to your ears. So if we break it down, a sound wave is just this repeating pattern of pressure. You've got spots where the air molecules are all squished together, that's called a compression, and then spots where they're all spread out, a rarefaction. And that repeating squish and stretch pattern, that's the sound wave. I love this way of thinking about it. Imagine the air is made up of billions of tiny, invisible balls. When a sound is made, it's like the first ball gets pushed, and it bumps into the next one, which bumps into the one after that. You get the picture. It's a total domino effect, a chain reaction of pressure that zips right through the air and into your ear. All right, so we've got it. Sound is a pressure wave. Easy enough. But here's the next critical piece of the puzzle. How fast does that wave travel? Because this is where helium comes in and just completely flips the script. So, in the normal air that we're all sitting in right now, sound moves at about 346 meters per second. That's pretty fast. Let's call that our baseline. It's the speed we're all used to hearing things at. Now, get ready for this. In helium, at the same temperature, sound just takes off. It travels at a staggering 1,020 meters per second. We're not talking a little bit faster here. This is a massive, dramatic leap in speed. And look at this chart. It just makes it so clear. The speed of sound in helium is almost 3 times faster than in air. And this one huge difference, this is the secret behind the whole helium voice thing. But why, right? What is it about helium that makes it so different? Why is sound traveling through it like a souped-up race car, while in air it's more like a reliable minivan? Well, the answer is actually pretty simple. It's all about mass. It's about how heavy the stuff is. Helium atoms are ridiculously light, tiny. The air we breathe, on the other hand, is mostly nitrogen and oxygen, and those molecules are way, way heavier. Think about it. What's easier to get moving, a bowling ball or a ping pong ball? The lighter thing, right? It's the same principle. Now, there's some fancy physics involved with square roots and all that, but we don't need to get bogged down in the math. The takeaway is super simple. The lighter the gas, the faster sound zips through it. Less mass equals more speed. That's it. So when you take a breath from that balloon, you're literally swapping out the heavy air in your lungs for this incredibly light helium gas. And what's the result? The sound waves your vocal cords make are now traveling through your throat and mouth about 2.7 times faster than normal. Okay, here it is, the big reveal. We know the pitch isn't changing. We know the sound is just traveling way faster. So, how do we get from point A to point B? How does that lead to the squeaky voice? Well, this is where we need to talk about a cool little concept called timbre. And let's just make this crystal clear, because it's the most important thing to get. The basic frequency of your vocal cords, the thing that we call pitch, does not change at all. You are not actually making a higher note. So, if the pitch isn't changing, what in the world are we hearing? Why does it sound so high-pitched? The secret isn't in what's making the sound. It's in the space that the sound is traveling through. Here's a great way to think about it. Your vocal tract, that's your throat, your mouth, your nose, it's like the wooden body of a guitar or a violin. The strings on the guitar make the basic note, the pitch, but it's the hollow wooden body that makes it sound rich and loud and like a guitar. That body is a resonance chamber. It shapes the sound. And your vocal tract does exactly the same thing for your voice.
And that special quality, that sound-shaping effect, it has a name: timbre. It's pronounced timbre. Timbre is the reason you can tell the difference between a piano and a flute when they're playing the exact same note. It's the flavor or the color of a sound.
Okay, so let's put it all together. Because the sound is racing through the helium in your vocal tract so much faster, that resonance chamber we talked about starts to act differently. It starts boosting all the higher frequency parts of your voice and dialing down the lower frequency parts. So the main note, the pitch, is still the same, but the quality of the sound has totally changed. It's as if someone cranked up the treble on your voice and turned the bass way down. Your timbre has shifted. And that, my friends, is the squeaky voice we all know. All right, we've had a lot of fun geeking out on the science here, but I have to get really serious for a moment. This is super important. Inhaling helium isn't just a funny party trick. It can be incredibly dangerous, and you need to know why. So please, listen up. Helium isn't poisonous, but it's what's called a simple asphyxiant. That means when you breathe it in, it pushes out all of the oxygen from your lungs. You're basically replacing the air you need to live with helium. This can make you dizzy and pass out in just a few seconds. And I cannot stress this enough. Never, ever inhale directly from a pressurized tank. The force of the gas can literally tear your lung tissue or cause an air bubble in your bloodstream, which can be instantly fatal. This is not something to mess around with.
So the big takeaway today is that it's not about pitch. It's all about how the density of a gas changes the timbre of your voice. Which leaves us with a fun little thought experiment. If a super light gas, like helium, makes your voice sound all high and squeaky by boosting the high frequencies, what do you think would happen if you were to inhale a gas that's way, way heavier than air? I'll let you think about that one.